Lesson 31, the unit circle. All right, so when we talk about something called the unit circle, I'm not sure, maybe you've heard of that, maybe you haven't. What it refers to is actually like a literal circle on a Cartesian plane, right? So here's our Cartesian plane. And if we said, okay, let's make the radius of this circle equal to 1, right? So it'd be 1 from here to here. It'd be 1 from there to there. It'd be 1 all the way around, right? Actually, it wouldn't matter where you were, right? It'd be 1 there. It'd be 1 there. And this is why it's called the unit circle. This is 1 unit long, right? So the definition of our unit circle is that it's going to have a radius of 1, right? So our terminal arm on this thing would always be 1 unit long. Hence the name unit circle, right? So this is going to be a useful tool for us for trigonometry, especially when we get graphing trigonometric functions. So let's start exploring this. So let's say if we started from, the center and drew our line from there to there, make that a different color. Drew that from here to here, right? And that was 1 unit long. Then we could say the point where it ends up meeting the circle would be at 1, 0, right? And that would be like our x value would be 1 and our y value would be 0 at that point, right? Similarly, if I go up to the top here, right there, that would be the point, 0. So my x value would be 0 and my y value would be 1. Now, let's kind of look at it in a different situation, though. Let's look at it now where we had a point, let's say right here on the unit circle. And I'm going to make that point just like, generic point x, y. Okay? And then I'm going to draw my line from the center there, from the origin, and then out to there. And I'll remember that this is 1 unit long, right? That's the whole point of this. Now what we can see, what we end up finding here, is if I made a triangle out of this, right? So if I made like a right angle triangle, so there's like my x value, and let's say there's my y up and down. And here, you know what? I'll make my y green and my x purple, so you can see the effect. Okay, then can you guys see what's going on there? That the length of this side of this right angle triangle, that really would be my x value there. Okay, so this is my x. And this is my y. So we're going to be able to use that when we start solving these, right? Because we know right angle triangles, right? This is a right angle triangle. So we're going to be able to use that fact that this is my x and this is my y to kind of do a little bit more below. And the other part of this, right? So this would be my angle that I'm creating right here. Well, can you guys imagine as this angle gets bigger, right? As it changes, well, that's going to change my x and my y. Can you see as it's getting bigger, my x would be getting smaller? And so as this angle is getting larger, my y, this green arrow would be getting larger. So the angle is going to affect what happens to my actual points on the unit circle as I go around. Okay? So that's probably good for that for now. Let's move on. So it's possible to do a little bit of math with these coordinates. Like for example, we can use Pythagorean theorem, right? We can use r squared is equal to x squared plus y squared, right? That's just c squared is equal to a squared plus b squared, right? But we actually just now know that our hypotenuse is our r, right? That's our radius, and our x and our y, right? So we're going to be able to perform, Pythagorean theorem with that. And then, like I was saying up there too, that last part just kind of explains the same thing I was explaining above there. So, all right. So, important features on a unit circle when r is equal to 1. All right. So before I get explaining these, so it says sine theta is our y value. Let's draw out a triangle. Let's draw out like that same triangle from above, right? It would be the similar thing there. So if I can draw a straight line here. All right. And you know what? Sorry, I'm messing with you guys. I'm gonna I'll make them green too. So that'll be my green side, and that'll be my purple side. Okay, and this will be my angle, theta. My radius here is going to be my r. And r is equal to 1, right? That's the definition of our unit circle. So I know that that length is going to be 1. And our x value, here we'll just say, so just remind ourselves, this is really my x. And this is really my y. I can make that look nicer. All right, so now if we look at this first part here, where do we get that? Well, let's look over at the y. Let's see if we can actually make an expression for our y value. Okay, so what if we did this? What if we just used our trigonometric ratios, right? Like our SOHCAHTOA. Nope. Right? To just rewrite this y, right? So this y would really be sine theta is equal to, and then sine is opposite over hypotenuse, right? So this is my opposite. My opposite is y, right? That's on the opposite side of my angle. So that's going to be y, and then over, and then my hypotenuse, this is the beauty of the unit circle and why this is actually going to work out so nice. This is really y over 1, right? Our hypotenuse is 1. So then when we said sine theta is our y value, well, that's why. It's because, you know, it's really just sine theta times 1, if you like. So then there you go. So we got, here, let's do that. And then maybe we'll say, therefore, sine theta is equal to y. Okay? So this is going to be a powerful tool, right? Because now, from now on, right, as long as I know what this angle is, I can pretty much figure out what my y coordinate is on here, right? So as long as I know what that angle is, I know what that y coordinate on that point is going to be. Okay, so that's a useful thing to know. Let's look at the x one. We got a similar situation here, right? But this time we're going to use cos, right? Because we have adjacent and hypotenuse. So that's going to be cosine theta is equal to adjacent over hypotenuse. So that's going to be x over 1. So therefore, let's write it the same way as above. Cos theta is just equal to x. All right, so if I ever have the angle, I can just take cos of that and get x. Okay. All right, so now with tan theta, right, so it says tan theta is actually just the y value over the x value. Well, that makes sense, right? Because tan, right, tan theta is equal to opposite over hypotenuse. Okay, so tan theta, our opposite is really the y, and our oh, sorry, opposite over adjacent, my bad. So our tan value, or our opposite is y, and our adjacent is x. So it's really just going to be y over x, right? And we learned from above that that would also be the same thing as sine theta over cos theta. Okay, so now, like I was saying above, if we want to find our x value, well, that's really just cosine of the angle. If we want to find our y value, well, that's really just sine of the angle. Okay. Now the other part, let's remind ourselves of this, right? So the cast rule. So if you guys remember, the cast rule tells us where the ratio is going to be positive or negative, right? So it starts in the bottom, so in the quadrant 4, it goes C-A-S-T, right? So try to remember that it starts down here. And then in this quadrant, it'd be all of the trig ratios are positive. In this one, just sine, tan, and cos, right? So let's actually just throw some numbers in here to remind you what I'm talking about here. So if this was our angle we were looking for, and let's say that this distance from here to here was 1. So this isn't the unit circle anymore in this case. Well, here, I'll make it 2, so it's totally not the same. So let's say this is 2, right? And this is like 2 up here. All right, so all this is saying is at this point, no matter which one we use, right, because this would be, our hypotenuse would always be like a positive value. Then if I did, let's say cos, that would be cosine theta is equal to adjacent over hypotenuse. So that would be 2 over this number, right? So that's going to be a positive number over a positive number. There, you know what? Just so we have actual numbers here. Let's make this a 3, 4, 5 triangle. Okay. So then that would be, yeah, for cos, that would be adjacent over hypotenuse. So that'd be 3 over 5. Do you see how that's positive, right? So that's positive. And that would be the same for sine and tan, right? So they're all positive there. But if I take this triangle and we move it on over here, right? Well, now this is negative 3, and this is 4, and this is 5. Okay, so in this case, if I did cosine again, that would be cosine of the angle, right? So of the angle is equal to, and then that's going to be adjacent, so negative 3 over 5, right? So it's negative, so cos is negative over here, right? But what if I do sine? If I did sine theta is equal to, and then sine is opposite over adjacent, so that's 4 over 5. Positive 4 over positive 5. So that's why it's positive over here. Okay? So that's all the CAST rule is really telling us. It's just telling us where these different ratios are positive and where they're negative, right? But we could always figure that out just by writing out the numbers and then using those as well, right? So, okay. So that was a little bit of review from 20-1. All right. The unit circle itself. All right. So before we get going here, we're going to do a little review on some special triangles. And we are going to focus on just this section for a second, just the positive section, because once we figure this one out, then the rest of them all just kind of fall into place. So let's focus on this first section to see if we can figure some things out here, right? The way this is going to be set up is this is just showing that you have, like, so this would be 30 degrees, this would be pi over 6, and then you've got your, like, what that actually ends up equaling there, right? For your point, I mean, so your x and your y. Okay. All right, so now to figure out this angle, which is going to be 30 degrees, this one, which will be 45 degrees, and this one, which will be 60 degrees, right? Those are going to be our special angles that we're going to be dealing with. Let's see if we can figure out what the sides are, right? Like if I split this one up into a triangle here, right? What would the x value be, right? This one. And what would the y value be? Because those really are what these are, right? That's my x and that's my y. So let's see if we can figure that out, knowing that we have a 30-degree angle on the unit circle, okay? But actually, you know what? First, let's do the 45 degree. Okay, so let's do the 45-degree triangle and see if we can figure this out. So if I drew a triangle, and this triangle has a 45-degree angle on that side and this side, right? Because that's 90. So they always add up to 180, right? So that's our first triangle. And knowing that this thing is on the unit circle, right? Like the length from here to here, we know is 1, right? That's the definition of our unit circle. And now we just want to use this to see if we can figure out what our x and what our y would have to be in this case, right? So at this point, you could use a trig identity here, right? You could actually just use, SOHCAHTOA, figure out what x is using that method. But we can also use Pythagorean theorem. So if we started off by saying x squared plus y squared is equal to 1 squared, right? Just Pythagorean theorem. So I'll just call that 1. Then can you guys see, like, on this triangle that x and y would actually be the same, right? If it's 45 degrees, then my x value would be the same as my y value. So I'd be able to say, okay, this is actually x squared plus, and instead of a y, I'm just going to call that x squared. And that's equal to 1. Okay, well, this would be the same thing as just, combine those like terms. That would be 2x squared is equal to 1. And then I'll divide by 2 and divide by 2. So now we have x squared is equal to 1 over 2. And then take the square root of that, right? So this would be x is equal to the square root of 1 over 2. Okay, now something's a little bit wrong with that. Like that is it, right? Like, so our answer here would be the square root of a half and the square root of a half. But typically when we're writing radicals, we don't like having a radical in the denominator, right? We want to rationalize that thing. So this would be the same thing, as the square, 1 over the square root of 2, right? Because the square root of 1, the square root of 2, so 1 over root 2. Now remember, if I want to rationalize that denominator, or get that denominator at the bottom, the little trick we do is we actually just multiply the top and bottom of this by root 2. Okay, so then we'd have x is equal to, and this would be root 2 over, and then root 2 times root 2, right? Anything, so that's like saying root 2 squared, isn't it? Well, the squared and the root would cancel, so that's really root 2 over 2. All right, so we figured it out. We now know that our x value here would be root 2 over 2, and so would our y value. It would also be root 2 over 2. All right, so we solved the first one. Now, while I'm filling this in, I might as well fill in what this angle in radians was, right? This angle in radians was also pi over 4, all right? And that would be using the methods that that we did in the first lesson there. You can also see that, you know, pi would be 180 degrees, right? And we've cut that thing into 4, so pi over 4. Because, you know, 1, 2, you know, so 1, 2, 3, 4, right? I drew that funny. 1, 2, 3, 4, right? So 4 spots there. Okay, good. So we found that one. Now, let's focus on the 30 degree, because it's actually going to be the same as the 60 degree to figure out what those are going to be. So hopefully you guys have some room here. Wherever you can on one side of the unit circle here. I'll start it from here. Okay, so in this case, what we're going to do is we're going to do a different special triangle. So in this special triangle, we're going to have 60 degree angles all around. And on this 60 degree triangle all the way around, every side is going to have a value of 1. Okay? So now in this case, we can do something here. What if we cut this thing right down the middle? Right? So we cut that thing right down the middle. So we just created 2 right angle triangles. All right? And if I do that, if I create that 2 right angle triangles, do you see that this would make this a 30 degree angle? Right? This would be 30 degrees now at that point, right? So let's make that a little bit more clear. So maybe I'll just draw that out now, like our new triangle that's been cut in half. All right, so now this triangle is 30 degrees and 60. And then this length here was 1 still, right? Because that was this length. But then what's this length? Right there, when we cut that in half. Well, do you see now that that'll be a half, right? Because it was a 1 all the way across the bottom, and now we're going to cut it in half. So there we go. So we have that one. So that really would be our x value, right? If we were looking at this, like the way I'm looking at this triangle right now, that would be like this triangle, wouldn't it? From like there to there on my unit circle, right? So our x value here is a half. So we can write that in if we want. We know that now that our x value would be a half, okay? We just got to find our y value, right? We got to find this, right? Which would be the height up and down here, okay? So to do that, let's do Pythagorean theorem again. So we can start off by saying x squared plus y squared is equal to 1 squared, or just 1. And now I'm just looking for y, right? But good news is I have x this time. So this is really 1/2. 1/2 squared plus y squared is equal to 1 squared. Okay, so now I'm just going to call this 1 over 4 plus y squared is equal to 1. And then I'm going to subtract 1 over 4 from both sides. So minus 1 over 4 and minus 1 over 4. All right, so we get y squared is equal to 1 minus 1 over 4 is 3 over 4. And then we'll square root both sides. So square root. So we get y is equal to the square root of 3 over 2. So there you go. There's our, it's already been rationalized, right? So So yeah, that's it. So our number here would just be, for our y, would be root 3 over 2. Now the good news is that actually handles our 30-degree angle too. So here, let's just finish writing in our angle in radians there too. So our angle in radians for that one would be pi over 3. Okay. And yeah, so there you go, pi over 3. Now, that was for that triangle. Now, if we're looking at the 30-degree one, right? So if I just make that into a triangle again, this is that same special triangle. This is this triangle, but now this is the 30-degree angle, and this is the 60-degree angle. So all that happens now is on the bottom here, instead of it being a half on the bottom, like it was here, now this is going to be root 3 over 2, and this is going to be a half for your up and down, right? So which makes sense. That's a half, and that's root 3 over 2. All right, we did it. We figured out what all of our special points are and special angles on our unit circle. Pretty much, because from here, now we don't really have any more, a lot of math to do. We really just have to follow our cast rule to figure out, where things are negative and where things are positive, right? And not even really the cast rule, just kind of using our sense here, I think. So let's start filling this in. Let's do this one first, right? So at the beginning here, this would be 0 degrees. And it would also be 360 degrees, right? If you went all the way around the circle and got back here. So 360. Or you could say that this was 0 pi or 2 pi. 0 radians, I should have said, sorry. 0 radians or 2 pi. Okay, so that point right there, though, that would be the point 1, 0, right? Let's go up to the top here now. So here, this would be 90 degrees. And it would also be the same thing as pi over 2, right? It's half of pi. This pi is over here. Okay, and this point would be at 0, 1. Now, let's start moving into the other territory here. So from here to here is another 30 degrees. Do you see how these are like in 30-degree chunks? It's like 30 degrees, 30 degrees, 30 degrees, 30 degrees, right? So this is another 30 degrees. So here is going to be 120 degrees, right? And that would be the same thing as 2 pi over 3. Well, when I'm done, I'm going to explain it. I'll show you guys the pattern that we're going to be able to see when we do these for radians. And you guys will have to memorize this as well. Okay, so yeah, be paying attention. Don't think, okay, I can just like forget this because I'll just keep on looking at the sheet. We do have to figure out a way to memorize this thing. So it's not as bad as you think once you see the patterns, I think. Okay, so as we keep going around, I'll draw my angles here first. So this would be the same as 135 degrees for your next one, which would be 90 plus 45, right, to get you there. So degrees. And then 150 degrees. Right, 120 plus another 30. And then we're back to 180 degrees. Which would be the same thing as pi. Okay, oh, I forgot my pi's on the other one. So that would be the same thing as 3 pi over 4. And this would be 5 pi over 6. Okay, now that we have that, let's figure out if we can find out what our points would actually be here, right? This won't be so bad because, like, watch this. So if I drew my triangle, let's say on this one, from there to there, right? So we knew that this was a half, and this was root 3 over 2. Okay, so for that triangle there. Do you see how this is just like a mirror image of that? So now this would just be negative a half, right? Because I'm going that way. And then it's going to be positive root 3 over 2. Okay, so this will be negative a half, comma, root 3 over 2. That's actually going to be the case with all these. You see this? How this one's negative, this one was positive. We're going to have that same pattern for all of them. Okay, so the next point here should be really similar to this one, right? So it's going to be root 2 over 2, comma, root 2 over 2, I just got to make sure I get the negative in the right place, right? And again, this will be my negative value, right? My x will be negative, so my x will be negative there. My x's will all be negative on this side. So maybe we want to put that. So you'd say, okay, when we're doing these ones, it's going to be like negative x comma y, right? And these ones over here were just x comma y. Okay, so then the next one would be like this one. So that's going to be root 3 over 2 comma a half, but that's going to be negative, right? All right, good. We're getting there. Oh, no, get rid of that. Okay, as we keep going. All right, as we go around, you know what? I'm going to just finish the rest of the angles, I think, as we go around here. So this would be 210, 225, 240 degrees. Those were all degrees. And 270. You guys probably know. Oh, I don't have a box on that one. Anyway, 270, 300, 315, and 330 degrees. Okay, and those in radians were pi over 7, or sorry, 7 pi over 6. What am I talking about? 7 pi over 6, 5 pi over 4, and 4 pi over 3, 5 pi over 3, 7 pi over 4, and 11 pi over 6. All right, that's all of our angles. Like I said, I'll explain a bit more about those angles here in a second. I'll show you the pattern. But let's write down our points here now. So in this case, do you guys see that this triangle, right? Again, if I go back up to the x-axis, well, that's the same as like this one and this one, right? Those are all going to be the same as far as the actual point is concerned, right? Our x and our y value. Okay, hopefully that didn't confuse you. Okay, so in that case, it's still going to be this root 3 over 2 and a half. We just got to make sure we get our negatives right. So we get root 3 over 2, comma a half. But then do you see on this case, this would be like a negative x value, right? That's going to be negative this way. This would be negative root 3 over 2. And then going down, this would be negative a half. So that's the way we have to write it for our point too now, right? So this is going to be negative and negative. And they're actually all going to be like that. This will be negative x and negative y's for all the ones in quadrant 3. All right, this point, well, that's going to be a lot like our 45s again, isn't it? But they're both going to be negative. So negative root 2 over 2 and negative root 2 over 2. And then on this one, we're going to have, well, that'll be the same as like my 60-degree angles up here, right? So that'll be the same as like this one and this one, right? Those are the same triangle. It's just happening down here now. Okay, but the same value for x and y, just got to be careful with our negatives. So that'll be our negative a half, comma, negative root 3 over 2. Just the opposite of that one, right? Okay, and then on the bottom here, this is going to be the point 0, comma, negative 1. And then as we move around, this one will be, well, the same as this, right? That's going to be like our 60-degree angles again. So it's like from like there to there, right? It's kind of what we're looking at. So then that one will be positive a half, right? Our x's are positive, but now our y's are still negative. So negative root 3 over 2. And then the next one would be our root 2's over 2's, right? Root 2 over 2, root 2 over 2. And the second one was negative, right? The y is negative. So let's write down that rule over here too. This would be x comma negative y. And then the last one, well, that was the same as these, wasn't it? So that was going to be root 3 over 2, comma, and then negative a half. And there you go. That's your unit circle. You just got to memorize it now. Okay, I'll give you guys a few hints on memorizing these things. One thing I want you to know too is that like it's great. Like I want you guys to do this. That the process of actually like labeling all that is valuable. I do have on the oh not that one on the course here. Um, where is it? Oh, just had to refresh there. I've got the unit circle on there, and this unit circle's it's kind of nice because it's already done. It's labeled maybe a bit nicer than maybe you did it if your writing's messy like mine. Um, so as we're going through here, let's look for some patterns. So, well, first off, I think we talked a lot about the patterns that happen with our x and our y here. So I'm hoping you guys see that one. But what about the like memorizing our angles and radians as they go around, right? Because we're going to have to memorize those things too, right? Okay, so the first pattern I want you to see here is that if we look at like pi over 6, right? Do you see that this is over 6, like something over 6, and then so is this one, and then so is this one, and so is this one, right? Those things are all over 6, right? And then the next ones, they have the same pattern there, right? All over 4, over 4, over 4, and over 4. And then the same thing on the top, over 3, over 3, over 3, and over 3. Okay, so that could kind of handle it if we were, for as a tool to memorize these things. We just have to figure out what the tops are. Well, in the first quadrant, it's pretty easy, right? Because they're all just pi over those things, right? But if we look over here, now we can see that they count up, right? So it's going to be like 2, 3, and 5. And if you're wondering, as long as they count up, you should be pretty safe because, it's not going to be 1 over 3 for the first one. It's not going to be 3 over 3 for the first one. The only answer that it could be is 2 over 3, right? I know it's something over 3, and it can't be 1, and it can't be 3. It's got to be 2 over 3, right? And then same with this one. If this one's over 4, wouldn't make any sense for this thing to be 2, and it wouldn't make any sense for that thing to be 4, right? Because if it was 2, that'd be a half, right? Which would be that. And if it was 4, then that would just be pi, which doesn't make any sense. So, okay, so that's the only option for that. And if this is over 6, well, then again, the same thing. If this is 4 over 6, then that would reduce to 2 over 3, which isn't right. And 6 over 6 doesn't make any sense either. Like they shouldn't reduce, right? They shouldn't be a reducing fraction. Okay? So, yeah, they count up as they go this way. And then as you move down to the next ones here, right? These ones, well, they count down if you're going this way, or they count up if you're going that way. However you want to remember it there. But then the same thing, like it's the only ones that make any sense here because, well, this has to be a little over 6, right? Because 6 over 6 would just be pi, so it's got to be a little bit bigger than that. So one, like just the smallest amount bigger than that would just be 1/6 more than that, right? So, okay. So look through those, see if you guys can see those patterns. A similar thing happens on that side. But just one thing to remember too, let's say that you forgot these and you didn't know what to do. Well, what you can always do, you can start from somewhere that you do know. So like pi, let's say, right? And let's say I forgot what this was from there to there. I didn't remember that was 7 pi over 6. Well, why not do this? You could go, what's pi plus, and then I know that this is pi over 6, right? That's how far that is. 30 degrees would be pi over 6. So what is pi plus pi over 6? Okay, so the way we handle those, because that's really like 1 pi plus 1 over 6 pi. We really just need to add the numbers out front, right? The coefficients. This is really saying like what is 1 plus 1 over 6? Well, that'd be the same thing as 6 over 6 plus 1 over 6. That's the same thing as 7 over 6 pi, or 7 pi over 6. Same thing. So we can always figure it out, right? Just by knowing, starting from like pi or whatever, and then adding or subtracting to get to whatever we want there. So same thing. If you wanted to figure out what this one was, if you forgot, well, that would just be pi plus, and then that's 60 degrees, right? Or pi over 3. Okay, so that would be the same thing as like 3 over 3 pi plus 1 over 3 pi. That'd be the same thing as 4 over 3 pi, or 4 pi over 3. Okay, so we can always get there that way too. But memorizing is a good thing too, just to kind of have these down. So yeah, I don't know. I think I like mine better. I don't know. The other one's probably better. Okay, so let's move on there. So now utilize the unit circle and solve for the exact value of these trigonometric functions. All right, so what does that mean? So I'm just going to remind myself here that y, or here, let's do this, sine theta really is my value for y. Remember, all the way up above there, right? If I was looking for sine of 315, I just really want to know what my y value is, like on the unit circle. That's why this is going to be valuable, right? So if you get a question like this, if you have your unit circle kind of memorized, you're like, okay, what was the y value at 315 degrees? So let's think that one through. I'll actually bring up the unit circle and just kind of show you what I'm talking about there. So 315 degrees. So that's right there, right? So 315. Okay, well, that's a half, right? My y value, oh, not a half, sorry, my bad. Can't keep going down. 315 was negative root 2 over 2. And that's it. That's all we have to do. We don't have to do any more math as long as you kind of have that memorized with that unit circle. So negative root 2 over 2. So that's it. So we can just say, and let's write ourselves a reminder here that this is really the y value at 315 degrees. Okay, so that was negative root 2 over 2. Okay, so now let's try this one. Cosine of 11 pi over 6. Okay, so cosine of 11 pi over 6. So 11 pi over 6 was the one that was close, right, to 2 pi. It was the one right here in radians. All right, so cosine is my x value, right? Cosine of the angle is my x value. So this is really root 3 over 2. Okay, so this is really just, here, I'll write the x, give ourselves a reminder again here too. So this is really the x value at 11 pi over 6. Okay, so then that was, what did we say that was? That was 11 pi over 6, root 3 over 2. There, don't even need a calculator on these ones, right? And that's kind of the thing. We're going to be doing these where you wouldn't even need a calculator if you have that unit circle utilized. Okay, now this one's a little bit trickier because it says, what is tan of 5 pi over 4? So in this case, this is going to be the, well, remember what tan was? Tan was the y value over the x value, right? So we'll have a little bit of math to do on this one. So we'll go to this and say, okay, 5 pi over 4. So 5 pi over 4 was right here, right? 5 pi over 4. Our x value is root 2 over 2, and our y value is root 2 over 2. So in that case, this is just going to be negative, right? They're both negative. So negative root 2 over 2 divided by negative root 2 over 2. All right, so dividing by a fraction is the same as multiplying by the reciprocal, right? So in that case, I'm going to change this up. This would be negative root 2 over 2 times, and then we're flipping these things, right? We're going to multiply it by the reciprocal, so this would be the same thing as 2 over root 2. And we get a bunch of negative, right? So a bunch of these things cancel. The square roots cancel, the 2's cancel, and negative times negative is a positive. So this is all equal to 1. And that makes sense for something that's at 45 degrees, isn't it? Because this is like one of our 45 degree spots, right? If the tan of the angle means that your x and your y would be the same, right? So the ratio of your opposite over your adjacent are going to be the same. Or they're going to be 1. Sorry, the ratio would be 1, but the numbers would be the same. Okay, now we have cotangent and cosecant. Yeah, So for these ones, if you still have them in your notes, we're going to do these after, like we'll wait till the next, till we cover cotan and cosecant. What they are, cotan and cosecant, just give you guys a bit of a preview. You've probably seen these on your calculator. Cotangent is really just 1 over tangent. It's 1 over tan. And cosecant is just 1 over sine. But we'll get there. So we'll do that first. Maybe you could figure those out, right? Just by knowing those things. Actually, you could potentially get there just by knowing that it is 1 over those. But we'll wait for that. Okay, last question here. So if we draw ourselves this out. So it says the following points lie on the unit circle. So G, which is that, and H, which is that. What is the angle that is formed by rotating from G to H in a counterclockwise manner? So, and then give our answers in degrees and radians. So in this case, our first point here, so this would be G, right? So if this was out here, let's say, that's going to be at the point negative root 3 over 2, comma, I'm not giving myself much room here, am I? Let's write that a liar. Negative root 3 over 2, comma, a half. Okay, so that's that point there. And then our other point would be at root 2 over 2, comma, negative root 2 over 2, right? So that's going to be like a positive x and a negative y. That puts me down in this quadrant, right? So that's going to be down here on our unit circle. And if you want to, maybe I should have just drawn the unit circle. Maybe I shouldn't. I'll leave it like that. Okay, so we'll do that. So this is going to be root 2 over 2, comma, negative root 2 over 2, right? That's where those points are. So what this question is really asking, it wants to know if you know what those angles are from there to there, right? So if this is the case, like you could figure out, you know, what the angle was from here to here, right? Because that's what our unit circle would be telling us. If we're looking at our unit circle, that would be 150 degrees or 5 pi over 6. And that'd be fine, but you know what's probably going to be more valuable is to know that this would be 30 degrees. If you can see my pen there, to the x-axis there, right? My reference angle would be 30 degrees. Okay? You could do it the other way too. Like it'd be fine to figure this one out and then it'd just be more work. I'm just going to know that this is really 30 degrees, right? And then, again, on my unit circle, if I'm looking at this one here, right, at 315 or 7 pi over 4, because that's where we have root 2 over 2 and negative root 2 over 2, well, that would be 45 degrees from there to there. Okay, so that'd be 45 degrees from there to there. And then this is 90. That's 90 degrees. Okay, so if we're going from point G, right, that was that one, to point H, then we could say it's so from G to H, and if we're going to go counterclockwise, right, so just this way, then that would just be 30 degrees plus 90 degrees plus 45 degrees. So this is going to be equal to 165 degrees. So there's our degrees. Now we just have to change the radians, right? So we know how to do this. If we have something as 165 degrees, I want to cancel those degrees, so I'm going to write this as pi over and then 180 degrees, so the degrees cancel, right? And if we do that and just simplify the 165 over 180, we get 11 pi over 12. Okay, so that's that. That's in degrees and radians. One thing I just want to show you guys is on the website, you will see under the unit circle here that I've put a unit circle memorization. So if you go into that, it's like a drill activity, and you can just try to get as many correct in a row as you can get, right? So this one will show you that angle. So you got to tell me what the angle in degrees is, what that angle in radians is, the x coordinate and the y coordinate, right? And then it'll just change. It'll just go through all the different ones, and you can just quiz yourself to make sure you actually have that thing memorized. I think this is a good idea, right? To go through and just make sure you have this thing memorized.